IOT Functional okay, basically introduction about me. I am Prof.P.Subba, working as professor with the Department of Computer Science and Engineering, Chalpati Institute of Engineering and Technology, Guntur, Andhra Pradesh, India. Today, in this lecture, I am going to talk about IoT functional blocks. An IoT system comprises of a number of functional blocks that provide the system the capabilities for identification, sensing, activation, communication and management. So IoT system does the following things: identification, sensing, activation, communication and management. IoT system the various blocks are device, communication, services, management, security and application. The various various functional blocks are device, communication, services, management, security and application. IoT communication models: request response, publish or subscribe, push pull, exclusive pair. Request response, it means basically the device sends a request and the system responds with a message. Publish, subscribe, push pull, exclusive pair. These are the four communication models. I won't go deep into them. First is request response. Send request to server. Client sends request to server. Server receives the request from client, processes request, looks up, fetches resources, prepares response and sends response to client. It uses the various resources. Server uses the various resources. Finally, it sends response to client. That is the request response communication model. Then you have publish, subscribe communication model. Publisher sends messages to topics. Message published to topic 1, message published to topic 2. Each topic, for example, topic 1 has subscribers, consumer 1 and 2, consumer 2, whereas topic 2 has 1 subscriber, consumer 3. The broker sends the message to consumer 1 and 2 because in topic 1 subscribers are consumer 1 and 2. In topic 2 subscribers are consumer 3. So in this, basically a publish subscribe communication model is present. Push pull communication model sends messages to queue and the messages are pushed to queue, messages are pulled from queues and sent to customer 1 and consumer 1 and consumer 2 if there are two consumers. Okay? Here push pull is used, so a queue is used, and it is basically from one thing to the other. Publisher pushes into the queue and the queue pulls out and sends to consumer. So that is a push-pull communication model. Then you have exclusive pair communication model. Request to set up connection, response accepting the request, that is connection is set up, message from client to server, message from server to client, connection close request and connection close response. Here there is one going from the client to the server and the other going from the server to the client. That's why it's called pair. So initially connection is set up, then the messages are sent, finally it is closed. IoT communication APIs. There are two types, REST and WebSocket. REST based communication APIs and WebSocket based communication APIs. REST based communication APIs. What does REST stand for? Representational state transfer. Representational state transfer is a set of architectural principles by which you can design web services and web APIs that focus on a system's resources and how system resource states are addressed and transferred. REST APIs follow the request-response communication model. They follow request-response, that is the first communication model. Request-response, that is the client sends a request to the server and server communicates back to the client with a response. The REST architectural constraints apply to the components, connectors and data elements within a distributed hypermedia system. The REST architectural constraints apply to the components, connectors and data elements within a distributed hypermedia system. What are the various REST architectural constraints? First, it is client server because it uses request response communication model. The principle behind the client server constraints is the separation of concerns. Stateless. Each request from client to server must contain all the information necessary to understand the request. The session state is kept entirely on the client. Cacheable. Cache constraints requires that the data within a response to a request be implicitly or explicitly labeled as cacheable or non-cacheable. Layered system. Layered system constrains the behavior of components such that each component cannot see beyond the immediate layer with which they are interacting. Uniform interface. Interface constraints requires that the method of communication between a client and a server must be uniform. Interface constraints requires that the method of communication between a client and a server must be uniform. Code on demand. Servers can provide executable code or scripts for clients to execute in their context. That's all I have for this class. Thank you.